Alright, so let us now see the results of the first coding exercise where we simply used a GRU layer and we've used 20 epochs. The mean absolute error is 0.28 and there is significantly overfitting. Now the mean absolute error, remember that we normalized the data including the temperature data. So we created a new variable z, so we subtracted the mean from each data point and divided by the standard deviation. So if you want to know what the true error is, you gotta take x here. Yeah. Alright, so the first thing we can do is dropout, and we've seen dropout in your traditional neural networks, but here we need to discuss recurrent dropout. Yeah. Remember, we have a memory here and we need to see how this impacts the memory. So one option would be to use traditional dropout, but it affects the memory ability of the network. There is an issue with the hidden states. Yeah. So another idea would be to apply dropout only on the input and the output, for example, and not touch the recurrent connections. And research has shown that there's still overfitting here. Yeah, so also not an ideal case. So the option 3 is the correct option, and that means that you're gonna apply the same dropout mask at each time step for the input and for the recurrent layer. And that is where the name recurrent dropout comes from. Yeah, so in Keras we will have our layer, LSTM or GRU. This is the number of units, and then we'll select dropout, and this dropout is on the input, and the input is your x. Yeah, and then we have a recurrent layer, and that has a recurrent dropout. Yeah, the recurrent dropout is the dropout in your recurrent layer. Yeah. Alright, so when we did this exercise with 40 epochs, we basically saw that the mean absolute error has not changed. It's roughly 0.28, but we solved the overfitting issue. Alright, now there's something else we can do. We can do stacking, so adding recurrent neural layers on top of each other. Basically the rule is, as long as you're not significantly overfitting, you have the capacity to make your network bigger, have more parameters, and it should usually give a better result. So that's the rule: increase the capacity of the network as long as you're not overfitting. For example, Google Translate uses 7 large LSTMs on top of each other. Yeah, it's quite a big network. How do we implement this in Keras? Well, there is this return sequences argument that we need to set to true. Yeah. So that means that, remember, we have these recurrent layers here, right? We had a few of them, and then at the end you have here your y predict, your outcome. Well, in this case we don't want this y predictor outcome. Yeah, basically the return here needs to be the full sequence, because we're gonna use that as the input to the next layer. So that's why you need to set return sequences to true. Alright? So when we did the exercise, we saw that the mean absolute error, was 0.29. And overfitting, no. Yeah. You could see at the end there's some slight tendency to overfit, but I put no here. The main issue here was it was slow. Yeah, it took a lot longer, this one versus this one. So you gotta take a look at, you know, computational needs and power versus accuracy.